Okay, so hopefully you listened to exercise 1, and this is going to be on exercise 2. A quick thing about exercise 1, just so that you guys don't get confused. I did talk about positive and negative controls. That is not the whole answer to number 2. That give you a little bit of a background, but there was a question that said, is more than one control tube necessary? What is the purpose of each test tube? I don't want you to automatically assume, okay, well, one's positive, one's negative. Think about it and make sure that you understand why you have those test tubes, okay? All right, so let's dive into exercise 2. Exercise 2 is going to investigate inhibitors. Specifically, the inhibitor we're using is xenothoria, or PTU, so I'll refer to it from now on as PTU. And this is a inhibitor that's specifically for catechol oxidase. Okay, it's going to combine with the copper in catechol oxidase, and it's going to inhibit that enzymatic activity. All right, so you do have two different types of inhibitors, and I'm going to write that here. So you have competitive, and then you have non-competitive. And of course, an autocorrect is trying to correct me. All right, let's move this over down a bit. All right, so with the competitive inhibitor, this is it's going to be structured similarly to your actual your substrate. And so you remember you've got your enzyme, your substrate, your product. Okay, so let's draw again. If this is my enzyme, and remember we're going to call this our lock, and let's pretend that this is our key, our substrate. All right. With something that is competitive, it's going to look very similar to our substrate. And it's going to block up, it's going to bind to the active site of where your substrate, your normal substrate, would actually go. So it's becoming competitive. It ties up the enzyme so it's not available for that substrate. Last year we did an experiment where we investigated starch blockers. Dr. Oz had said that the starch blockers are amazing because they bind to the enzyme that would normally break down starch so that your body doesn't absorb it. It wasn't true. It didn't work. So that's the whole point of an inhibitor. However, competitive inhibitors can be reversed if the concentration of the substrate is raised to a very high level. So if you increased catechol to a very, very high level, that inhibitor is not going to inhibit the actual enzyme, and so it won't work basically. Non-competitive inhibitors. All right, so the difference between competitive and non-competitive. Let's draw our enzyme again. Again, remember this is our lock. We have our key. Now, a non-competitive enzyme, and we're just going to do a little bit of a thing over here. Non-competitive enzyme is not going to actually it's not competing for the active site. Okay, so it's not going up here, but instead it's going to go here. By binding to a different spot on the enzyme, it's kind of going to distort part of your lock. Think of it as like melting part of your lock, and so then our substrate is not going to fit. And if it doesn't fit, it's not going to create our product. And no matter how much substrate you flood into your test tube, it is not going to stop this reaction. And so any additional substrate is not going to reverse inhibition. In this activity, for exercise 2, you're going to prepare again 3 test tubes. And so let me get rid of these. Get rid of my drawings. Get rid of this. All right. So we are going to have our 3 test tubes again, and let me draw those out. So we've got test tube number 1. Again, they look like beakers, but just bear with me in my drawing. So that's test tube number 2, test tube number 3. 1, 2, 3. All right, and let's pull up the amount that's there. Hold on for 1 second. All right, so here we have our table of contents. Let's take a look here. So test tube number 1, and we've got our 5 milliliters of distilled water in all. All the actual amounts are going to be equal in all 3 test tubes. So test tube number 1 has our distilled water, it's got our potato extract, it's got our PTU, more distilled water, and our catechol. All right, so that's test tube number 1. Test tube number 2, distilled water, potato extract. Again, we've got our PTU, and we've got an increased amount of catechol. So between 1 and 2, the amount of catechol is increased. Let's take a look at number 3. Test tube number 3 has the distilled water, the potato extract, no PTU, so no inhibitor. And to make up for that, it's going to have distilled water, and it's going to have catechol. Let's take a look at our results. So let's see, I'm gonna go through here, and what I'm gonna do, again, I'm gonna crop it so that you guys just see the amounts. All right, done. All right, so let's take a look here. Test tube number 1, clear. Test tube number 2, clear. And test tube number 3 is that bruising color. All right, now you have the results. What I want you to do, I would like you to go into exercise 2, and I would like you to answer the questions 2 through 6. So which test tube is the control? Why is the concentration increased? Etc., etc. I'd like you to design a table of your results. I've given you results. You're listening to the results. Design a table, and then answer the 2 discussion questions. So explain your results in terms of your hypothesis, and how could you explain the experiment to provide additional evidence to strengthen your conclusion. All right, so do that, exercise 1 and exercise 2. We are going to do exercise 3 in class, and this is a concentration, pH, and temperature on amylase. All right, I'll see you guys in a couple of days.